Hello, this is Dr. Claire, and today we're going to be talking about the rules of probability. Now, probability is a very useful tool, particularly in Mendelian genetics and population genetics, and since we're going to be talking a lot about Mendelian and population genetics in this course, I want to go over the rules of probability so that you can use these tools when we're talking about these biological subjects. Now, it may be kind of daunting to learn about probability, but it's actually not that complex. It's just addition and multiplication and a whole lot of logic. So you just got to kind of think your way through it, and I'm sure you're going to be fine. So the first thing to bear in mind with probability is that the probability of any particular event occurring, or the probability of getting a particular item, is equal to the frequency of that item in the population. So, for example, let's say you have a sock drawer, and in your sock drawer you have red socks and you have blue socks. And if you close your eyes and you grab a sock out of the sock drawer, what's the probability that you're going to grab a red sock? Well, you've got 7 red socks out of 10 total socks in the drawer, and so the probability that you're going to draw a red sock when you close your eyes is going to be 7 out of 10, or 70%, or 0.7. All of those are interchangeable. They all mean the same thing. Okay. So another example, if you have a six-sided die, not surprisingly, has 6 sides, and so the probability of rolling any one of those 6 numbers on the die is going to be 1 out of 6. You have one chance out of a possible 6 opportunities to get that particular number. All right, the first rule of probability that I want to tell you about is the addition rule. The addition rule tells you the probability of either of 2 mutually exclusive events occurring. What does it mean to be mutually exclusive? That means that 2 things can't happen at the same time. Your sock cannot be simultaneously red and blue at the same time. It's either red or it's blue. And so the probability of the addition rule is what you would use when you're trying to determine the probability of drawing a red or a blue sock. Did you hear what I just said? A red or a blue sock. So if you turn a probability problem into a sentence, whenever you hear the word or, you should be thinking addition rule. So the probability of pulling a red or a blue sock is going to be the sum of the probability of pulling a red sock and the probability of pulling a blue sock. So let's take a look at the dice again as an example. So what's the probability of rolling a 6 or a 1? That's going to be the probability of rolling a 6, which is 1 out of 6, because there's 6 sides to the die, and plus the probability of rolling a 1, again, 1 out of 6. So 1/6 plus 1/6 is 1/3, and that's the probability of rolling a 6 or a 1, okay? So one thing to remember with probabilities is that the sum of all possible probabilities is always going to equal 1. So if you have this 6-sided die, right, there's 6 things you can roll on a 6-sided die. You either roll a 1, 2, 3, 4, 5, or 6. There's no other options. So if you add the probabilities of all possible options together, that should always equal 1. It doesn't matter what you're looking at. If you go back to your sock drawer, you've got your 7 red socks, you've got your 3 blue socks. Probability of pulling a red sock is 7 out of 10. Probability of pulling a blue sock is 3 out of 10. You add those together, you get 1, right? So the sum of all possible outcomes is always 1. Okay, and that's going to become really important in population genetics because we're going to be looking at the probabilities of different genotypes, and those probabilities will always equal 1. Okay, so just bear that in mind. Just tuck that away for future reference. Okay, all right, so let's say we've just calculated the probability of rolling a 6 or a 1 as 1/3. So what's the probability of not rolling a 6 or a 1? Well, all of the possibilities add up to 1. So if you didn't roll a 6 or a 1, you had to have rolled one of the other things. So if you just subtract the thing that you're trying to get rid of, and not rolling a 6 or a 1, so the probability of rolling a 6 or a 1 was 1/3. The probability of not rolling a 6 or a 1 would be 1 minus 1/3. And this is a very useful trait of probability as well. Okay. The second rule of probability I want to talk to you about is the multiplication rule. And the multiplication rule tells you the probability of 2 independent events happening at the same time. So what does it mean to be independent? Independent means that whatever happens with this one event doesn't influence the other. So let's say we're flipping coins, and you flip a coin and you get a head on this with this coin. And you have another coin, and you go to flip that coin. Is the fact that you got a head on the first coin going to influence the probability of getting a head on the second coin? No, because they're independent of each other. Whatever you get on the first one is not going to affect the second one at all. So So let's say we want to know the probability of flipping two heads. So you flip a head on the first coin and a head on the second coin. Now you'll notice I said and that time. So with multiplication rule, if you turn your probability question into a sentence, wherever you see the word and, you should be thinking multiplication rule. So the probability of getting one head with one coin and a head with the other coin is those two probabilities multiplied together. So the product of those probabilities. So the probability of flipping a head with one coin is 50%. You have heads and tails, so there's only two options. Probability of flipping a head on the other coin, also 50%. And so 50% times 50% is 0.25, 25%. And that's how that would work. So let's take a look at our dice again for an example. So what's the probability of rolling double sixes on dice? Well, the probability of rolling a 6 on one die is 1 out of 6. The probability of rolling a 6 on the other die is 1 out of 6. You multiply those together and you get 1 out of 36. So let's look at something that's a little bit more challenging. What's the probability of rolling an 11 with two dice? Now, how can you get an 11? And you're going, okay, yeah, you need a 5 and you need a 6, right? Okay, but you have two dice. What if you get a 5 on this one and a 6 on that one? That's one opportunity. But what if you get a 6 on this one? Can you still get 11? Yes, because you could get a 5 on this one. So there's two different ways to get an 11 with two dice. You can get a 5 on the first die and a 6 on the second die, or a 6 on the first die and a 5 on the second die. So I said that very strangely because I'm putting in those ors and those ands. So 5 and 6, or 6 and 5. So wherever I'm saying and, that's going to be a multiplication. Wherever I'm saying or, that's going to be an addition. So you would do 5 and 6. 1 6 times 1 6, that's 36. 6 and 5, 1 6 times 1 6, that's 36. And then you add those together to get 1 18th, right? So 1 out of 18 times that you roll two dice, you're going to get an 11. Okay, so hopefully that makes sense. And that's my quick introduction to the rules of probability. So it's just the addition rule and the multiplication rule. If you guys can master these rules and the language that goes with it, you'll be able to nail a lot of these probability questions. So go ahead and do some practice.